All right. Hello, everyone. Welcome back to week 3. This will be the first lecture of the 2 for our summer course. So we've got a bunch of stuff on the whiteboard for the day before we start actually getting into material, continuing with 2.1 where we left off, and then going through 2.2 completely as well by the end of today. So I need to keep this as short and sweet as possible, even though I've got about 8 or 9 minutes of stuff to talk about. So reminders, traditional Mymathlab homework 1.1, 1.2, and 1.3 had all been finished by last class, which means they are due on the 8th and 10th based on when we finished them. Remember, all due dates are 11:59 p.m. This is one of the last times you'll see that time marker for anything Mymathlab related, discussion board related, etc. I might put it up there for the midterm just to be, super specific, but you should know by now 11:59 p.m. is the due time. We will finish 2.1 and 2.2 today in their entirety, so they're due in 1 week. Reminder that your Excel 1.1 is going to be due today as well, that heart rate. I've had a few people emailing me about this one, and I'd like to remind you that the Excel assignments are supposed to be much more student-driven. I can answer stuff occasionally, but I can't answer specific things like what do I type in this box or how do I do that. These are things you're supposed to be learning through watching the lectures, through watching the extra little tutorial videos, which I'll remind you where they are because that's going to be super important, going through the homework, et cetera, et cetera. But remember, you do have 6 attempts actually for that heart rate one. I know I said 5, but that's just to, for, what's the word I want to look for? It doesn't matter. That's just to get you used to them always being 5, because starting with the TV loan, it will actually be 5. This is a legit 5 attempts. So this is our second traditional Excel assignment, 1.3 TV loan. And on top of those tutorials that I've given you, on top of the tutorials in Mymathlab that I'll remind you where they are very shortly, there are also in your guided activities that you can download or print or buy, whichever of the 3 you're doing. There are pages that I've pointed out that go over most of, if not all of these Excel assignments. They don't tell you what to do, but they ask you some questions that would be very helpful in completing it. And quite often they show you the completed charts. So maybe when you're doing 1.1 heart rate and Excel, the grader is telling you you're losing points for your chart, maybe take a look at that workbook and see what their chart looks like, compare it to yours, and maybe you've got extra stuff in there, which is pretty common for that heart rate one, which is something I've brought up to a student or two. But again, these are much more student-driven. I can answer a question or two, but I'm not going to be, guiding you through the assignments, tutoring you, anything like that. I am going to send out the tutoring request form today or tomorrow if you do need more hands-on help with that specifically. So you see video quiz 1. This is not our first quiz. This is our first video-based quiz. And this is not based off videos that I have done. These are based off videos in Mymathlab. Actually, I'm sorry. Let me step back for a second because I skipped this because I have it higher than it should have been. One last thing with the Excel. Sorry, I had to cough really bad there. I did show you how to make an addition or multiplication table. I said that that's going to help prepare you for Excel 1.8 BMI. There's going to be another 1 or 2 Excel files where these mixed cell references, these fixing a row, fixing a column, stuff like that. It's going to be important periodically in here. So this is what I had suggested that you make in order to prepare for that, because you'll know what the answers are supposed to be for making an addition or multiplication table, I hope. Whereas making a BMI table, you're not going to know what the answers are supposed to be, so you can't say, does this make sense necessarily? So don't forget to do that as practice. Don't turn it in. It's just practice. Do it 50 times if you have to, but do it. All right. Video quiz 1. Again, not our first quiz. This is our second quiz, but it's the first one based on videos. You will download the file in Canvas. There's a spot to download it, and you will upload it in Canvas. It's a second spot to upload though, because of the way document stuff works in Canvas. It's silly. And again, I pointed out this is based on Mymathlab videos, not my videos. So where is this quiz? Well, when you go into Canvas, lecture videos, quizzes, boom, they're open now. This is where you go to download the quiz. This is where you go to submit the quiz. It's either 4 or 5 questions. I believe it's 4. Some of these, you're going to have several of these throughout the semester. Some are 4, some are 5. And again, you download here and it'll be a PDF or a Word file. I think it's a Word file. Yep, it's a Word file. And you can download the document here. It'll actually preview the questions here. And I was right, it is 4 questions. And you can see the first one is just describe how to get to the videos. I mean the Mymathlab videos, not my videos. Don't you dare say go to Canvas. The first thing you should say is go to Mymathlab, spoiler alerts. If you talk about my videos, you're gonna get it wrong. Then the next 3 questions, which is more traditional for these video quizzes, it will tell you which specific video to go to. Spreadsheet tutorial video, formatting cells with percent style. Okay, so I need to find the spreadsheet tutorial video based on formatting cells with percent style. So go to Mymathlab. We go to video and resource library, and these instructions were given to you day 1. It's also in a document. You can do all chapters, or I know chapter 0, spreadsheet basics, that's where it's going to be. And then make sure you click video, find now. And boom, here are all the spreadsheet tutorial videos. These are the things I was talking about a few minutes ago. We're specifically looking for the one formatting cells with percent style. So you just got to use your eyes and find the one that says formatting, blah, 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 percent style. And admittedly, my eyes are not the best. I'm finding it. Here we go. And that's the video that you would watch to answer the question. Do not just copy paste what the author verbally says and write it down. Put these in your own words. You know, it's technically plagiarizing when you copy what someone else says verbatim. So put these in your own words. You don't necessarily have to say the whole sentence or paragraph the author says. As long as you are conveying the message, I will give you full credit. There are questions where one word can be the answer, a sentence could be the answer, or maybe if someone does a paragraph and and all 3 of those different students get it right. That's fine, as long as you're conveying the message. Convey it well. So you got one on fill formulas, another one on fill formulas. So questions 3 and 4, same video. It's like you get a 2-for-1 practically. Be careful answering these. Make sure you understand them. Make sure you submit them properly. You can type them or handwrite your answers. And then when you go to, oops, I gotta go back to home. That's what's wrong. And then when you finish your document, when you save it, take a picture of it, whatever, then you go in here and you submit it, and you should be able to find the button. I have to manually grade these, and it usually takes me about a week to get to all of them. So just have patience. I am pretty generous with the grades as long as you answer the question correctly. Again, I'm not necessarily looking for perfect grammar, perfect sentence structure, anything like that. I'm a math teacher. I don't care about that stuff. So just please, please, please make sure you get the answer conveyed well. These are not timed quizzes. You have as much time as you need it because you're just downloading a document. You can take 5 minutes or 5 hours and then submit it, but it is due. Again, you have your due dates up here. Discussion board 1, due today. Discussion board 2, due by 11:59 p.m. next class. I am not assigning a discussion board. You'll hear me lightly talk about one coming up. Admittedly, we are going to skip it. I'm trimming the fat just a little here and there for this summer course, and that was one of the things I cut was a discussion board. I'm going to cut a quiz later. Not that you'll ever know because it's going to be cut. All right. So was one more thing I was going to say. When we get to 2.2 today, we're going to start talking about how you can keep track of your grades in here. This is one of those classes where they say teach a person to fish and they can be fed for the rest of their life without just giving them a fish. So instead of me giving you a fish, I'm going to teach you to fish in here. Don't ever, I've mentioned this before, but don't ever ask me what your average in this course is. And remember that you've got grades in Canvas, you've got grades in Mymathlab. Both of them kind of lie about your averages. So what will ultimately end up happening is I'm going to email you an Excel file. An Excel file? Well, I never, an Excel file. It's like we're learning with Excel. And that is going to be a wonderful resource to keep track of your grades because I've got all the formulas set up based on the weights of this course, based on 15% for this, or 5% for that, or 20% for this. So you can just say, all right, well, I got a 95 on Mymathlab 1.1 after Mr. Beckner's curve. So you go to the Excel file and you write 95 in that little spot, and then everything adjusts. Oh, okay, I got a 79 on the midterm. You write 79 in that Excel spot and everything will adjust. So after we talk about how do we find weighted averages today, next class, I will show you that Excel file, I'll show you how to use it, and then I will email it out. But let's not waste any more time. Let's pick up back in 2.1 where we left off, talking about proportions, talking about ratio tables, talking about that guided activity, and yeah, here we go.
We had done this. We talked about how we can use proportion or ratio tables to find, as long as we know that the table is set up in a proportional manner. Just because you have a table of numbers doesn't mean it's proportional. Someone has to tell you that, or you have to establish it based on patterns and things like that. And the main pattern is whenever one thing doubles, the other doubles. You could say it as one triples, the other triples, as one quadruples, the other quadruples, but proportional means a constant multiplier between them. Just like 2 apples triples to 6 apples, the 3 oranges triple to 9 oranges. If it may be on Wednesday, there were 10 apples sold, that means they sold 5 times as many apples, which means they'd sell 5 times as many oranges. Now, does a store's apples and orange sales have to be proportional in the real world? Absolutely not. They could actually be what's known as inversely proportional if maybe there's a sale on one of these things, so people are going to buy way more apples than oranges, or vice versa, whichever one's on sale. So again, in the real world, you might have to put your brain cells together and figure out whether they are proportional or not, and then extrapolate from there. But we said the wonderful thing about a proportion table is that they don't have to be all just sitting next to each other to set up the fraction equal to a fraction and cross multiply. There can be giant gaps between them, and very often they are in the problems that we have to do. But it doesn't matter. You don't need any of the numbers in between, as long as you can imagine yourself drawing a box around some numbers. And when you do that, you have 3 corners of numbers and a blank. And it doesn't have to be the bottom right blank. There could be a number here and the top left is blank. You just set fraction equal to a fraction. We've discussed the 10 different ways. I mean, a rounded number, the 8 different ways you could set it up. It could have been 2 over 3 equals 6 over x. It could have been 2 over 6 equals 3 over x. It could have been 6 over 2 equals x over 3. It could have been 6 over x equals 2 over 3. It could have been x over 3 equals 6 over 2. It could have been x over 6 equals 3 over 2. I mean, I don't even know how many ways I just said in that lightning bolt amount of time. But all of those would have led to the same answer of x equals 9, which in this table, it was limes on Friday. Whereas before, the smaller table, different fruits, different days, just to prove a point. Again, you will see this over and over in this course, especially with something called a consumer price index. We'll get into that later. So what we did from there is we pulled up our guided worksheet, and we were talking about how, okay, we have some births based on a population. We said maybe we shouldn't base it off of the whole population, maybe just the number of women in birthing age. We wanted to find out how many births there would be if there was only a population of 1,000 people. This is scaling. It's not scaling to 1, it's scaling to 1,000. We could also say that there's 60.2 births for every 1,000 women of birthing age. So that's another scaling. You can use that idea to go back and find out how many birthing aged women there are. What we did together last time was we used these simpler numbers of 4, 8, 12, 8 ended up being there, 500, 1,000, and etc. Whatever number that happens to be. Whatever off the top of my head, that's okay. So what we're going to do this time is use the more legit numbers with these ugly decimals, etc., etc. Not decimals, just millions and millions, and we'll have decimal numbers. They say to round to 2 decimal places. Remember, you have to pay attention to this. Mymathlab marks things wrong when you round wrong. Round to 1 decimal, it's wrong. You round to 3 decimals, it's wrong. Maybe on a test, if you showed some work and mentioned it to me, I can give you partial credit. So I said maybe. If you didn't show your work, no partial credit. Now, do you have to have an entire page of work to get partial credit? No, I just have to see something. Otherwise, I can't say, well, you didn't prove that you actually figured this out in any way, shape, or form, so maybe just pull the answer off the internet. I don't know. That's not the point of quantitative reasoning. You can use the internet as a resource, but not to do the answer. Okay, so this is in a proportion table. They said everything was based on proportions, so our goal is to find the B and the W. And they give you some space to fill out the work. I don't like using the annotation that way, as you have seen multiple times. So let's just do the work over here. Now, move this a little more, because I can't see all the numbers. Good enough. Numbers and variables, that is to say. So they called B for births. Now this B is specifically representing when the population is 1,000. So this B is the number of births per 1,000 people. 1,000 people. And the W would be the number of women of birthing age and the total population. So you've got to pay attention to your rows and columns and how things set up. Everything is relative. This B isn't based on the whole population. It's based on if the population was only 1,000. So it's scaled. So we talked about how scaling things to 1 or 100 or 1,000 can give us sometimes prettier numbers, sometimes easier numbers to relate to. Like if you scale something to 100, you can think of it as a percentage. Population things are very often scaled to 1,000, just to kind of eliminate 3 places, if you will. Yeah. So imagine yourself drawing a box in such a way that you'll have 3 numbers and a variable in the corners. So just really quickly, if you do like this is not going to solve for the B. First of all, the B isn't in a corner. And you got 3 numbers in corners, it would actually solve for this right here. If you used this number, and this number, you could go 3.8 million over 60.2 equals 324 million over X. But I was not asked to find the population if there's only 1,000 women of birthing age. So again, scaling down the population. We weren't asked to find that. Don't find that. Can you find it? Yes. Would you have maybe a job that makes you find all of these blanks? Maybe. Is that our goal? No. We're only finding these 2 specific things. The number of births per 1,000 people and the number of women of birthing age. So don't do more than you have to. We're just going to do this as our box. So the 3.8 million over the B equals the 324 million over the 1,000. All right, so 3, and I'm going to abbreviate, come on, don't do this to me today, 3.8 million over the B is equal to the 324 million. Now when I do my calculator, I will write the numbers in appropriately. You cross multiply, so you'll get 3.8 million times 1,000 is equal to 324 million times the B. Again, the M's are abbreviations for millions. Don't think they're variables, please. 3.8 million times 1,000 is just going to make that billions, so it's now 3.8 billion. I'll write the word because there's another B. So in other words, it's just 3 more zeros on this number right here, 472, 000. That'll be equal to the 324 million number times the B. How do you solve that very simple equation? You divide both sides by the number with the variable, 324 million. And that tells us that B is equal to, let's pull out our calculator. So 3,853, let me clear all that stuff. That was from my other class earlier. 3,853, 3,853,472,000 divided by that 324 million number, which is 324,459,463. And we get 11.87, blah, 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 blah. We're rounding to 2 decimals, so 11.88. Don't forget, when quantitative reasoning, make sure you understand what exactly you're answering. Don't just give this number. This is not the answer. The answer is, so it's 11.88 births, because that's where we were births, and then it's based on a population of 1,000 people per 1,000 people. That's what's happening there. That's what that number means. It's 3.8 million births for 324 million in population. It's about 12 births per 1,000 people in population. If our births was 60.2, again, we could figure out what that X was some way, shape, or form. I've already described, but we weren't asked to. It's not really an important number, so we don't. The next thing we were tasked with finding was this W. So if we try and draw a box, now you could certainly do this. I'm going to say I'm not going to, but you could. You could draw your box this way, because then you've got number. We now know this number. Wait, we don't know that number over there. Excuse me, I'm thinking that I had the number there. So we can't. I'm going to say that didn't make sense to myself like we do with quantitative reasoning. I caught myself and I said, there's no number here, there's no number here. So that's 2 numbers and 2 blanks. But the point of me bringing this up was this right here, this B was rounded. So this 11.88 is a rounded number. If you use a rounded number to find another one in a proportion table, this is going to have something called error truncation or error propagation. You use a number that's been rounded to find another answer, and then round that, and then use that to find another answer, and then round that. These rounding errors end up causing bigger errors down the line. So maybe this answer is supposed to be, let's just say it was 12.5. That's completely wrong, but it's supposed to be 12.5. But with your number, you get 12.6. Mymathlab might mark it wrong, and that's because you used borrowed information to move along. So my suggestion is to try and only use, when you can, the numbers prescribed to you. I guess I could have just hit clear. There we go. So we know this is the end of it, so I got to draw the box that way. Now you might say, okay, can I do it this way? Can I do it this way? Can I do it this way? Well, no. Number, number, blank, blank. So that fails. Clear. Maybe we need to go down all the way. Could I do it like this? No, because there's a blank here and a blank here, so that fails. But if you do it across the whole entire table, excluding labels, remember labels are not numbers in a proportion table, they're just labels. We got number, 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 and the variable. So there is what we need to draw up. All right, but I do have to clear that. Come off of annotate. Scroll down. So that would be, I'll do it in a different color. We'll do black this time. 3.8, the million number, over the 60.2. Remember, it's this number over this one. This is the easiest setup in my opinion. Equals the W over 1,000. We cross multiply. We'll get the 3.8 million times the 1,000 equal to 60.2 times the W, which is 3.8 billion equal to the 60.2 times the number of women of birthing age. Divide both sides by 60.2. If you can't do this very simple algebra, you have got to practice it 1,000 times before you can. And then do the calculation. So the 3, 8, 5, 3, 4, 7, 2. And then there was the 3 more zeros from multiplying it by 1,000. And we're dividing it by 60.2. And we get 6401162.79. Now, they said to round to the nearest 2 decimal places, so that says that W is equal to 6. Wrong color. 6401162.79. Actually, our calculator, because it can only handle so many numbers, went ahead and rounded it to 2 decimal places for us. But what exactly is this? This is women of birthing age. Now, very often when we're talking about a large number of people, we don't really like decimals. If we're talking about a couple of people, like, hey, the average household is 4.2 people or something like that, that's when we'll leave a decimal with people. But it's really hard to have 79/100ths of a person. So the rule of large numbers kind of states that you just round that to the nearest whole instead. So 6401163, which would be 64,011,163. I knew my comma placement wasn't perfect there. Let me just rewrite the number. I can do better than that. 64,011,163 women of birthing age. That's the answer. It's not 64 million people, 64 million women of birthing age. Remember, you're supposed to be doing these and then asking yourself if it makes sense. Well, if the population is 324 million, does it make sense there's about 64 million women of birthing age? Well, about half the population is women, so half of 320 million is about 160 million. And there are women younger than 15. And the biggest portion of the population is the people under 21. So there's a lot of women under 15, girls, whatever you want to call them. I don't care about labels. And then there's a decent amount of women over 44 as well. So I'd say this is a pretty good ballpark answer. What do I mean by does it make sense? How do I really say this number makes sense? What if I forgot to multiply by those zeros and I said the answer was 64,011? What's going on? If I said the answer was 64,011 women of birthing age, would that make sense? Well, if there's 324 million people we're discussing this relative to, I don't think 64,000 women of those people are able to give birth. It's way more than that. That answer would not make sense. Or maybe I had too many places. Maybe I said that there were 640 million women. How would there be 324 people on the world, or in our country, excuse me, in our country? How would there be 324 million people in total, but there's 640 million women able to give birth? That's more than the population. That wouldn't make sense. You have got to learn to do that after every single answer of anything in a quantitative reasoning sense, which is pretty much the entirety of this class. All right, so next up, what we're going to do is that far enough over? Yeah, that's far enough over. Okay. So the next thing we're going to do is we're going to talk about college tuition, because what do we all pay, or someone pays for us? College tuition, right? So they have a column for private four-year schools, which are historically the most expensive. They have a column for public four-year schools, traditionally the in-between. And then they have a column for the public two-year school. So the left is our private schools, oh man, what is the local one? I'm blanking. Let me come back to it. Then we have our public schools like ODU, Virginia Wesleyan. There we go. Now I remember. So private four-year, this is kind of like our Virginia Wesleyan, but averaged across all of them. This middle one's like our ODUs and our Norfolk States and our VCUs and our Virginia Techs and UVAs. Then this right column is our TCCs and our Thomas Nelsons and all the other ones like that. So our community colleges are the cheapest by far. Our ODUs and CNUs in Norfolk States are kind of middle of the road. And our private schools that are not governmentally funded. So since Uncle Sam's not helping with the bill, you got to pay the whole thing. $30,000. So they're saying these were the average tuition and fees across a whole bunch of different places. In 2013 and 14, these numbers have gone way up, like tuition does. But that's okay. Old numbers are fine to understand. So what's going on with this table? What's this 1 right here? What's this 100 right here? What's this 1 right here? Ignore this multiply bit for a second. I've already alluded to that earlier when I was talking about apples and oranges. All right, 2 apples on Monday, and then it's 10 apples on Wednesday. So that was a multiplier of 5. So if you have 3 oranges on Monday, that means the other day you multiply that by 5. Basically, it's the ratio between some stuff. Okay, so this 100 is like scaling the private four-year to a percent. So if 100%, if you're paying 100% to go to a private four-year, what percentage of that are you paying to instead go to ODU or CNU? What kind of answer would you expect? Probably something in the double digits, like 15%, 30%. You wouldn't expect it to be 5%. You wouldn't expect it to be more than 100%. The fact that this number right here is bigger than this number here should be true across the entire columns. The fact that the 8893 is bigger than the 3264 should be true across the entire columns. All of these numbers in the first column should be the biggest, all the numbers in the middle should be in the middle, and all the numbers on the right should be the smallest. Now, that's just based on how I set this up, or how they set it up. If you swap all the public and private four-year numbers, then the biggest ones would be on the right, smallest on the left. Okay, so scaling this to 100, the private 4-year, that'll be like us saying, all right, well, what percentage are you paying in comparison to a private 4-year to go to ODU? Maybe like 20%. What percentage are you paying to go to TCC? Maybe like 10%. Scaling things to 1 is like, okay, for every $1 you spend in a public 4-year school, how many dollars do you spend going at a private, if you wanted to go to a private 4-year school instead? And you would expect that to be more. Every $1 you spend here is going to be $3 or $4 or $5 or $10 here because of the 9,000 versus 30,000. On the contrary, for every dollar you spend at your ODU, you're going to expect to spend less than $1 for TCC. So these are the things you should be saying or going through with the does it make sense aspect. If I got an answer right here that was 5, it would not make sense because that would say for every dollar I spend at ODU, I would instead be spending $5 at TCC. No, sir, no, ma'am. If it's $1 at ODU, I should be spending, I don't know, 30 cents, 40 cents, 10 cents, 20 cents, somewhere in the cents ballpark. And again, that's for every dollar. So down here, this says for every dollar you pay going to TCC, if you wanted the same education, how many dollars would it cost to go to ODU? Again, $1 at TCC is going to cost you how many dollars instead at ODU? Or if you spend $1 at TCC, how many dollars would you be spending at Virginia Wesleyan? These ones are really awesome for the multiplier effect. For example, let's just say, I'm making this up. Let's say it turned out to be for every $1 you spend at TCC, it's $5. Again, this is wrong. If it was for every $1 you spend at TCC, you would instead spend $5 at ODU. That means that if I spent $100 at TCC, I would instead be spending $500 at ODU. If I spent $1,000 at TCC, that means it would instead cost me $5,000 at ODU. If I spend $10,000 at TCC, it would cost me $50,000 at ODU. So scaling things to 1 is a great way to give us just a multiplying effect. That's what this is alluding to, that will go into greater detail when we have the real answers. So our ultimate goal is to fill out this table completely. We didn't do that last time. We just wanted a couple of the boxes. This time we want everything, the whole shebang. You're not ready for this yet. Let's give us some space. Okay. So fill in the table of values in the ratio table. They tell us it's a ratio table or a proportion table, which is awesome. It means we don't have to prove it. For the greatest accuracy, you should always try to use the original statistics in the first row of numbers in the table. This is what I alluded to earlier with accuracy. So when I get this answer of, say, about 3.5, spoilers alerts, all the plurals, spoiler alerts. When I get about 3.5 here, if I don't have to, I don't want to use that number to find this blank, this blank, this blank, this blank, or this blank. I want to try and only use the 1, 2, 3, 4, 5, 6 numbers they gave us. Maybe you can't, maybe you can, but that's your first effort. Okay, the order of the blanks you tackle these doesn't really matter. I'm going to tackle them in this order. I'm going to label them A, B, C, D, E, and F. Please work. Did that work? It did, okay. So I'm going to try and find A first. Remember, you're trying to draw a box. And I'm not going to actually literally draw the box every single time. It's going to get tedious. This was going to be a guided activity for y'all, but there's only 6 answers and I got a lot of students, so it's okay. I want to go through it together. So we take the 30,000 over the A and set it equal to the 8893 over the 1. Again, this is my box. 3 corners have numbers, 1 has a blank. Can you see that? I hope you can see that. I'm circling around these 4 spots. So we're going 30,094 over A equals 8893 over 1. Remember, there's arguably 16 different ways I can write this proportion with those 4 values and variables and still get the answer right in the end. There's also plenty of ways we can write it wrong. My favorite is top over bottom equals top over bottom. Cross multiply. I'm not going to show every single step. 30,094 times 1 is 30,094 equals 8893 times A. 8893 times A divide both sides by the number with the variable, divide by 8893. And we ultimately get, calculator, I don't know why I have to do that sometimes. It's clear, 30,094 divided by 8893, 3.38, blah, 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 blah. Now they know where it told us how many places to round to. You can choose to round to 2, you can choose to round to 1, it's up to you. Sorry for the little ink over there, I just don't want to remove those. I'm going to round to 1 decimal place for this one. You could certainly round to 2, because I didn't tell you where to round. You could round to 2, you could round to 3. I'm going to choose 1 for this one. So that's 3. I hate that it does that when I go back to Word. 3.4 is equal to A. So that's a 3.4. Now, again, I could use that number to find a couple other spots, but I'm going to avoid it if I can. Now let's try and find B. Can we imagine ourselves drawing a box around B in some manner? Well, you're not going to be able to do it down here in any way because these are all blanks pretty much. So you're going to have to go above it. So maybe the whole thing, could you do it this way? You certainly could. If I go around all 6 of these values, I'd be using the 30,000, the A, the 3,200, and the B. But that uses a borrowed number, a rounded number, and I suggested that we try not to do that. So while it does work, you'll get a close answer. It won't be exactly the same as what I'm about to do. So I'm going to draw my box this way. I still have 3 numbers in corners and an unknown. So I'm going to go 8, 8, 9, 3 over 1 is equal to 3, 2, 6, 4 over B. Again, this is the box. These 4 right here, all snug next to each other. Cross multiply, you get 8, 8, 9, 3, B equals 1 times anything is the anything, so 3, 2, 6, 4. Divide both sides by the 8, 8, 9, 3. To tell us that B is equal to 3, 2, 6, 4, 3, 2, 6, 4, divided by 8, 8, 9, 3. And we get 0.367. Now, because this number is not a whole, you might say, well, you rounded the first one to 1 decimal place, so 0.4, and that's okay. It's not bad. But because this number doesn't have any holes to it, I'm going to be very loose in how I round. Even though I rounded the last one to 1 place, I'm going to round this one to 2. Does that mean you have to know to do that? No. You can call that 0.4, but I just feel like this gives it a little more accuracy. And you might say, all right, well, since I rounded that one to 2, maybe you go back and round the previous one and you call this 3.38. Again, that is perfectly fine in the real world. All right, let me try and not use too much space. So that was B. Do these answers make sense? Okay, for every $1 you spend at ODU, that means we would be spending A, $3.4 at Virginia Wesleyan at a private university. I think that makes sense. It's a 3.4 multiplier. So if you spent $1,000 at TCC, that means you'd be spending $3,400 at Virginia Wesleyan. If you spent $10,000 at TCC, you'd be spending $34,000 at Virginia Wesleyan. That's the convenience of scaling to 1. How about B? For every $1 you spend at ODU, you would spend 37 cents at TCC. Again, that makes sense. You should be spending less than what you're spending at ODU. All right, let's try and get C. I'm going to skip drawing a million fake boxes just in the interest of time. But again, try and practice this on your own. After you see these answers, go back and try and replicate them. Don't just listen to me and say, this is how I drew the box. Figure it out on your own. Okay, so this discussion board, this group work is just going to be independent, and I'm not going to ask for the answers because I want every single one of you to do this, not just 6 of you. So C, if we do the box like this, that would be not good because we'd have 2 blanks. We'd be using C and D. So how about this? There we go. The 30,000, the 8,800, the 100, and the C. We're ignoring the A and the 1 row. We're going corners. 30,000, 8,800, 100, and the C. So 30,094 over 100 is equal to 8893 over C. Cross multiply, you'll get 30,094 times C is equal to 100 times 8893. Just tack on 2 zeros, 889300. Divide both sides by the 30,094. Make sure you're doing your algebra correctly. Again, you are supposed to be experts of algebra at this level, not crazy algebra experts, just the simple stuff. And yes, this is simple stuff. Do your math. So 8893, 00, divided by 30094. And we get 29.55. It's got a whole summing around it to one decimal, 29.6. So this is your 29.6. So that says for every $100 you spent at Virginia Wesleyan, you're only spending $29.6 at ODU. That's one way you can think of it. But the way I prefer to think about it when you're talking about scaling to 100 is a percentage. So if you're calling the private school 100%, that says that ODU only costs you 29.6% in comparison to Virginia Wesleyan. That's what that says. So because this was 100, that's calling 100% the Virginia Wesleyan type school. This says that ODU type schools would cost 29.6% of that. D will be a similar type answer. And I'm going to draw my box this way. I hope you can see that. Around the 30,000, the 3,200, the 100, and the D. Yes, I could draw it this way using the C and D, but then I'm borrowing a rounded number, which would give slightly different answers. So again, 30,000 over 100 equals the 3,200 over the D. 30,094 over the 100 equals the 3,264 over the D. Cross multiply, 30,094D equals 326400. Divide, I'm going to skip showing all that work and just do it in the calculator. So we get 326400 divided by 30094. And we end up with D equals 10.8. Again, rounding to 1 because of the holes. D equals 10.8. So does it make sense? Well, I hope so. If 100% is the private school, 29.6% is ODU, 10.8% is TCC. So TCC costs 10.8% as much as a private school. Again, if those were the actual numbers, which are not, these are averages. E and F, very similar. To get E, I'm going to draw a box around this whole thing. So the numbers I'll use, the corners are the 30,000, the 3,200, the E box, and the 1. Whoops, I didn't mean to click that. Uh-oh. Uh-oh. Oh, that's just silly. Now they're not going to be in the right place. I'm not erasing that and rewriting it. You know where the boxes are. Sorry about that. My calculator back up. I didn't mean to click something is what had happened there. So the 30,094 over box E equals the 3,264 over the 1. So now we're saying for every dollar we spend at TCC, how many dollars would we be spending at the private school? Cross multiply, we get 30,094 equals 3,264E. Divide both sides by the 3,264. 30,094, oops, went too far. Divided by 3,264. And we get our answer. The E, does that look right? I did this intentionally wrong, believe it or not. 92. So we're saying for every $1 we spend at TCC, we're spending almost 100 at that. That doesn't seem to fit the rest of the bill. I mean, it is bigger, but it seems like we made a mistake somewhere. And it wasn't in the algebra over here. It was in the calculator use. I hit 0 one too many times. So let's try again. 30,094, not 300,094. There we go. Divided by 3,264. But if you don't pay attention, if you don't ask yourself these questions, you're going to assume it's right because your calculator said it, and you're going to get it wrong. So 9. Shouldn't say hate. 9.2. I dislike equals E. Hate's a strong word. So for every dollar we spend at TCC, we're spending about $9 at the private school. That seems to fit the bill a little more 3,000 versus 30,000. That's about a multiplier of 10 to go from one to the other. So 1 to 9.2 is a multiplier of about 10. All right, finally, to get F, I'm going to draw my box in this way. And again, you don't have to literally draw the boxes. It's just visualizing them ultimately. 8893, the 3264, the F, and the 1. So 8893 over the F equals the 3264 over the 1. Scaling things to 1 is also awesome in the proportions because it's just 8893 equals 3264 F. Divide by the 3264. Spoilers, I'm going to do this wrong. I'm going to divide wrong. I'm going to do 3264 divided by 8893. And I get 0.367. So that says for every dollar I spend at TCC, I'm spending 37 cents at ODU. That doesn't make sense because ODU is more costly. Oh, I goofed my algebra. Instead of dividing by the 3264, I divided by the 8893. So let's fix that. We asked ourselves if it made sense. We checked our work. We didn't just trust a calculator blindly like so many people of the world. Trusting data blindly, trusting computers blindly. 2.72 or 2.7, since it is a whole, it has a whole number in it. And again, I chose to round in this way. I would never care if I don't tell you how to round in a test. I would not have a preference, but your tests will tell you to round. This is not a test style question where you have to figure out how to round. This is a real life scenario where you just kind of choose the level of accuracy. You could have chosen 2 decimals for all of them. You could have chosen 1 decimal for all of them. You could have gone to 3 decimals. Whole number, a little too much rounding for some of them in my opinion, but you certainly could have. And that of course was F. So does that make sense? For every dollar we spend at TCC, we're spending about 2.7 at ODU. Yeah, I think that makes sense. These things are about a 3 times multiplier. This is about a 3 times multiplier. All right, let's clear our screen. Go off of annotate. Question 6 refers to that multiply thing I was talking about, going from here to here. Multiply by what? So how would you go from here to here, just doing a multiplier and not cross multiplying? Because cross multiplying is one way to solve proportions and to do things, but when you scale to 1, you don't necessarily have to cross multiply and all that jazz. You don't necessarily have to set up a proportion. You can use that, oh, okay, well, we went from 2 apples to 10 apples, that's 5 times as many. So if we have 3 oranges, I'd expect 5 times as many oranges. 3 times 5 is 15. You can use that concept. So question 6, what number do you multiply by? I'm going to put the annotate on for this, to go from the values in the 2nd row to the 3rd row. So we're trying to go from here to here. So multiply by what? Where the numbers we had in place were, this was a 3.4, this was a 9.2, this was a 29.6, I had to write this down, this was a 2.7, 0.37, and 10.8, 10.8. This idea of multiplying by is all centered around the 1. That's your anchor. So we're going from row 2 to row 3, row 2 to row 3. So you find the 1 in row 2, and you find out what value it turns into. It turns into a 29.6. That is your multiplier. This right here is the multiplier, the number that the 1 references to. Now, if I said if we were trying to go from column 2 to column 3, that would not be the multiplier. We'd be going this way from the 1 to the 0.37 instead. So we have to pay attention to what they asked. So we multiply by 29.6 to get row 3 values. So instead of doing all those proportions and stuff to find the 29.6 and the 10.8, check this out. Let me take it off of annotate. Pull up my calculator. If you don't trust me, why am I still on annotate? I said off of annotate, you silly goose. So this 3.4, I'm saying if you multiply that by 29.6, you'll get 100. At least close, 3.4 times 29.6. That there was rounding involved, so it might not be exact, but that's freaking close to 100. This 0.37, if you multiply it by by 29.6, 0.37 times 29.6. 10.95, 10.8, really close. So that's a good quantitative idea. So when we have a 1, it's really nice in terms of the actual application of saying, all right, for every dollar we spend here, this is how much is spent here, this is how much is spent here. But it's also amazing for filling out other parts of a proportion table without cross-multiplying and solving, cross-multiplying and solving. Now, again, are these answers exact? No. Are they good enough in terms of rounding in real world? Yeah, sure. How could we have made them more exact? Have more decimal places. Okay, so what about the other part? How do we go from the third column to the first column? How do we go from the third column to the first column? Well, the third column is this column. There's a 1 in it, which is right here. Back to annotate. So we're starting in the third column and we're going to the first column. So this 1 points to the 9.2, which is that's the multiplier. So that's the second part. So from the third column to the first column, that's what I'm answering now. You would multiply by 9.2. So to have gotten the 3.4 or the 100, if that was a blank, you can just multiply anything in the third column by 9.2 to get the first column. Don't trust me? Oh, I know why. I just figured that out. I got to remember that, why I kept accidentally coming back to annotate. So let's take the 10.8 times 9.2. And again, both of these are rounded values, so it's not going to be exactly 100, but it's close. If you take the 0.37 and multiply by 9.2, won't be exact, but it's pretty close, 3.4. That one's actually really close. And the closeness is going to vary. I'm not going to talk about the reasoning behind it. But yeah, these are just some awesome things that you can use. Scaling to 1 gives us a way to fill out a proportion table quicker because we won't have to set up proportions. We can just use multipliers. Scaling to 1 is also awesome because it enables us to do that. All right, for every 1 here, how many about over there? How many over there? Scaling things to 100, great for percentages. Pardon my cough. What do I have? About 5 minutes. I don't have enough time to finish that one, which sucks. That's where I wanted to do that, but I don't have time. That's frustrating. Okay, so what I'm going to do is I'm going to make a statement. Let's clear my screen. Off of annotate. Back to the Word file. Not that Word file, the other one. Maximize it again. So just kind of a note. You may come back and complete page 6970 together or as a DB discussion board. It shows us writing ratios to 1 or to 100. It takes one of the examples for number 2. It does them in one way, then in number 3, it flips them to make sure that you're paying attention. So instead of going big number to small number, it asks you to go small number to big number. Question 1 we'll skip. It's not that relevant to what we need to do. But it's just questions 2 and 3 really. 2, 3, and 4, excuse me, that we'll do later. And again, I might do it. It might be a discussion board. We'll see.
Sorry, just had to set up for 2.2. Here we go.
Move on to 2.2, weighted averages. So I've had a couple people at this point, which is pretty typical, email me asking about their grade because Mymathlab is a pain and doesn't display the zeros that you've earned if you didn't actually open an assignment. So it might say you've got 100 when really you've got like a 10 because you only did one out of the 20 homeworks maybe by the end of the semester. But unfortunately, all your grades aren't in Mymathlab. You've got grades that are in Canvas and things like that. They're in two different locations. Canvas will have these ghost assignments, which I've had like 2,000 emails about, and I'm hardly exaggerating. Hey, why does it say this? When does it due? Everybody's panicking because they think they've got assignments that they missed. And no, it's just placeholders. So things like that can screw up a gradebook too. So when you ask me what is my grade in a quantitative reasoning course where we're supposed to the moral whatever you call it, teach a person to fish and they can eat for the rest of their life instead of just giving them a fish, that kind of idea. So I will never ever 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 tell you your grade in this course. You, the quantitative reasoning student, are responsible for figuring that out yourself, and we are going to teach you how to do that today with something known as the weighted average. Now, this technique can be used to calculate your grade in pretty much any course, as long as you have a teacher that uses a weighted system, which there are very, very few teachers that don't. And even the teachers that might say, like, all right, we have 1,000 points throughout the semester, and your tests are worth 400 points, and your quizzes are worth 100 points. That's still a weighted scale. It's just everything's been scaled to 1,000 instead of 100, so that 400 points for your tests is really 40%, 400 out of 1,000. And we'll get into all that stuff later on how we scale things, which we've already kind of introduced with proportions and ratios. But for this class, I've told you your Mymathlab homework is 15%, your quizzes 15%, Excel homework 15%, projects 5%, participation 10%, midterm 20%, final 20%. Where can you find this? In the Yes, You're Right syllabus. So a weighted average is when someone says or something says, this item A is more important than item B, so we're going to give it more weight. And more weight means that it has more effect. So if you earn, say, let's say you have a teacher that just weighs everything exactly the same, and you get an 80 on the midterm and an 8 and a 100 on the final, and everything's weighted the same, you'd end up with a 90 based on the old school average, which is just add up the data and divide by the number of data. Also, I give you the technical name here, which is a mean, because the term average, there's three types of averages. You have the mean, the median, and the mode. Median being the middle entry, mode being the most common entry. But we usually stick to the mean for averages. Notice I said usually, not always. When we like to talk about things like the average salary of an American, the mean and the median give two very different answers. And in fact, most people with an educated background would agree that the median in that instance is better, and we'll get into that another day. So the old school average is just add up all the data and divide. But so if you had an 80 on a test and 100 on a test, you'd get 80 plus 100 divided by 2, and you'd get 180 over 2, which is 90. So your grade would be a 90%, which would be an A. That's the old school average. But a weighted average is where we say, well, this category is more important. The test is worth 20%, and the homework's 15%, and the project's 5%. Those are weights. Weights are assigned values that tell you how important they are. And the larger the value, the larger the weight, the more important they are, the more that they will sway that average, that weighted average. So when we're doing weighted averages, you can do them kind of like I just did up here, but again, this is not a weighted average. The formula is peeking its head down below. We'll get to that in a second. But you can do it by hand, as we'll do several of today. But you could also make Excel do all of your work for you. So this can be used to get your, I'm sorry, I'm jumping the gun here. This old school average, pardon me there. I forgot to read this line. I saw Excel and I got excited. The old school average can be used just to calculate your Excel averages. So we've got 2 Excel grades right now currently, not 3, only 2, because we've only done heart rate and what was it called? The TV limb. Remember that chapter 0 file did not count as an Excel file. That was a participation grade because you literally just copy pasted. You didn't have to do any thinking or creating. It was just watching and repeating. That's a different type of assignment. So you could take your 2 Excel grades right now, add them up and divide by 2, and that will give you your Excel homework average. You've got like what? How many are officially? Oh.
All right, at this point, I kind of stumbled trying to remember how many Mymathlab homeworks there were, and at this point, it's 3, 1.1, 1.2, and 1.3, which means that you could add up those 3 and then divide by 3. So if you had an 80, a 90, and 100 on those 3 homeworks, you add 80 plus 90 plus 100, and then you would be set. I just got to pick up the right spot.
I had said the Mymathlab homeworks, you add 10 points to if they're a 90 or lower, or you make them a 100 if if they were higher than a 90. So a 95 goes up to a 100. 90 would turn into 100, so nothing over 100. So yes, when you create your own gradebook, which I'll kind of show you a skeleton next class. I think I'm going to do it next class because I started building this morning and I'm not quite done. I don't know if I want to show the unfinished product yet. Maybe I will. Maybe I will. So no, you're not rounding your Excel averages or anything like that. The Excel grades are the Excel grades. It's the Mymathlab grades that you could have up to 10 points out of 2. Now, if you get a 0, you don't add 10 points to that. You didn't do anything. I'm not giving you 10 points for free. And then your quizzes, like I said, I think we've had 2 thus far, although 1 is due tonight. Now you might say, well, Mr. Beckner, the syllabus quiz you gave us was out of 4 points. Does that mean if I got a 4, that's a 4%? I got a 4 out of 100? That sounds awful. I got everything right. Why did I get a 4? Well, no, silly. That's a scaled grade. It's 4 out of 4, which would be 100. If you got a 3, 3 out of 4 would be a 75. A 2 out of 4 would be a 50. You just do the division and scale it to a percent. If you got a 3.5, you take 3.5 divided by 4, move the decimal twice, boom, there's your actual grade. So don't let those confuse you. Don't write your syllabus quiz as a 4 or a 5 or whatever it might be. You scale it to a 100 so that everything is in the same measure. So you'll have to do that on your own, or again, you can have Excel do that. And you know what, I am going to go ahead and show you what I started. So this is something I've made as a project before. Honestly, people do quite terrible at it. I'm not going to make it the project this semester. I'm just going to show you what it can look like. So again, this is started. This is not finished. I did this in about 3 minutes while setting up for class. So I've got a column for all my different Mymathlab homeworks, and this is not a big enough column because we're going to go through chapters 9 and 10. Maybe not 10, but you'll need to have the spaces there. You'll have a column for your Excel grades. This is more than we need, but that's okay. A column for your quizzes, also more than you'll need. Your participation grade, which, I mean, if you've been participating, you've got a 100. If you haven't done a single thing, then you've got a 0. So remember to participate. Project grade, blank, we don't have any yet. Midterm, no final. So those all should have nothing in them, but you could definitely have 100 for your participation. So maybe I got a, not a 50. Let's go with a 81 on my Mymathlab homework 1.1. That was really hard to say with all those my's. So I got a 71. I made an 81 in my gradebook. Then in 1.2, I got a 95. So I write a 100 in my gradebook. 1.3, I got an 89. So I write a 99 in my gradebook. Now what I can do down here at the bottom is, after all of them, and again, you might need more columns. So in fact, let me just paint more of these. Wait, that was weird. I didn't mean to do that. Paint more of these. Fill the grids just for fun. I said fill the grids, you silly goose. And then down here, I'll have AVG for average, and I can go equals average, open parentheses. So this is kind of like sum, it's a built-in function. And then I can just highlight all of these. I don't just highlight the ones I've got, because then when I put a grade in for 1.3, it won't be considered in for the average. So you just highlight all of them. And again, I might need more rows than that. I think I need like 2 or 3 more rows than that technically, but good enough for government work for now. So I can see my average is a 90.5 in that column. And then my Excel grades, maybe I got a 10 on the first one because I didn't want to do it, or I just did one tiny little thing. But then I said, well, I can't do this all semester. I got to get my act together. And I got a 91 on the TV loan. And then I get I don't know, an 87 on the BMI. Big improvement. And then down here, average, I'll keep it the same abbreviation, AVG equals average. Open parentheses, highlight all of the cells for all of the grades now and future. So my average is a 62, and as I keep making better and better grades, you'll see that get better. So let's say on the next one, don't remember the name, but I get a 99 on it, average goes up. Next one, I get a 100, average goes up. Next one, I get a, I don't know, 85, it was a tougher one. Average still goes up. And then my quizzes. I get a 100 on the first one, I get a 75 on the second one, whatever. And then you can have the average down here. I've already shown you how to kind of set that up. And then somewhere else, I'll have to show you the formula another day because it's just, we haven't gotten to it yet. I have my weights over here, so I'll be using references on those, and we'll come back to that. So what's this weighted average formula look like? It looks like this. Your weighted average, not just an old school average, your weighted average. So a regular average is just add up a bunch of things and divide by the number of things. The sum of weights is technically the number of things. It might not feel like it, but it is. It's as close to being related as it can. So what's going on with this formula? There's this dot, dot, dot at the end. Does that mean it's unfinished? No, it's finished. So it's weight 1 times data 1. So what I mean by weight and data, so let's talk about, maybe this one is the Mymathlab homework section. So the weight would be the 15%, because that's what your Mymathlab grades are worth, 15% of the total grade, and then times whatever you got for your Mymathlab average. So right now, looking back at that Excel file, my Mymathlab average was a 95. So then I could do a times 90.5. And then weight 2, this could be the Excel bit. So you would have your 15% times whatever grade you had for your Excel average, which was this 78.7, we'll round it. So 78.7. And then plus, and then you'd have the quiz section, then the participation, midterm, final project, all that different stuff for your grade in this course. So it's how much it's valued at times what you actually earned for that section. Or if it's not talking about averages of a grade, it might just be a cost of something, as we'll get into with our examples. So the top is the weight times the grade, or weight times the data, weight times data, plus weight times data, plus weight times data. So it's, you're multiplying a weight and a data, and then adding, and then the next weight times data, and then adding the next weight times data, and then adding the next weight times data. This is known as a sum product because you're adding up a bunch of products. The bottom is the sum of the weights. So this would be like your 15% plus the 15% plus the 5%, et cetera, et cetera, et cetera. All the different categories of grades that we just related to. But one small issue is you're generally going to be responsible for identifying which is the data and which is the weights. Now, I just explained for a grading system, the weight is the percentage that's set up in a syllabus, for instance, and then the data is the grade you earn. And then this pair of sentences is just, or triplicate of sentences, I suppose, is just explaining everything I just said out loud. The top is adding a bunch of weight times datas. The bottom is just adding the weights. Sometimes the bottom is 101, sometimes it isn't, and that's when we're talking about grades. If the class is completed, if you've accounted for all categories, then the bottom, you'd be adding up all 100% of your different grades. Or 1 if you're doing it as decimals instead of percentages. That's what I mean by that. But if you're not talking about a grade system, the bottom can be what the heck ever it wants to be. So this is your formula. You have got to memorize this idea, this formula. I will not give this to you on a test. This is a fact of life. I know my Z's look a little weird because I put a line between them. Kind of a British thing, I think. Or at least I learned it from my British teacher in college. So maybe there's an assumption there that's wrong. Either way, not the point of the problem. Weight times data plus weight times data plus weight times data plus weight times data. So we're going to do several examples of this. We're going to start with something much simpler than our grade in this course. And one last sentence before getting into the example down here. Oh, and I left all that stuff. I'll have to erase some things so I don't just show you all the math at once. But when we're talking about grades, your weight is typically what a grade is worth, not the grade itself. Again, the grade itself is what you earn. What the grade is worth is me saying it's 15%, it's 5%, it's 20%. When you're talking about items being purchased, it tends to be the number of things purchased because the more you buy, the more weight that category will have. All right. So our first example before we get into the guided worksheets. So this is just a random example I have made up. So say we've got a class where you have the following weights, only 3 categories, much simpler than quantitative reasoning in terms of layout, right? So we have 50%, sorry for that, I just dropped my book on my desk. You've got 50% for your homework, 25% for your midterm, and 25% for your final. So those are our weights, 3 categories. I'm not saying there's only one homework assignment. That's you find your homework average, and then that grade counts as 50% of your grade. You don't apply that 50% to every single individual homework grade. That would be extremely tedious. You just do the regular average, and then you apply the 50%, as we'll see. And yes, I think I meant to say that, but the reason I put the line through my Z's is so they don't look like 2's. That is exactly why I do that, because I have terrible handwriting, and it's worked for me for 20 years. All right, so 50%, 25%, 25%. So currently, this is important. Currently, oh, you know what? I don't want to do this example yet. This is the hard one. Darn it. Let me make a side example for this. So I'm going to copy the first part. That is a much harder example that we'll do later. Currently, you have an 80 on the homework and a 78 on the midterm. What is your current average? There we go. That other one, I forgot that last little bit was an extended concept. We'll circle back to that at the end. So your weights are still the same, 50% homework, so that's half your grade, then 25% for the midterm, 25% for the final. Currently, you have an 80 average on all your homework. So I'm not saying you have an 80 on just 1 or 2 homeworks. I'm saying you have hundreds and 95s and 72s. You add them all up, divide by the number of homeworks, you got an 80 as your average. And you earned a 78 on the midterm. So these grades are pretty close to each other. What is your current average? Now, we're not just adding 80 and 78 and dividing by 2, because this is a weighted system. We have to account for that. So our weighted average. First, it's important to note what the weights and what the data are. The 80 and the 78, these are our datas. These are the things that we earned. These, I mean, I literally say that they're the weights, so I don't think I need to write that again, but these were how much each category weighs, how much it counts for. The larger the number, the more it counts for. So your weighted average is a big old division, where it goes weight 1 times data 1 plus weight 2 times data 2, and you just do that for all of the different categories. So if this was a completed course, notice I said if, I'd have 3 of these. I'd have weight 1 times the homework grade, then the midterm weight times the midterm grade, then plus the final grade times the final weight. I said those last 2 in the opposite order, but it doesn't matter. But there's no final. I didn't say what we have on the final exam. So when things are missing, you need to skip the missing grades. So I'm not going to have 3 sum products in the top. I'm only going to have 2. I'll have the 50% times, so that's the homework category, so times the homework grade, which was an 80, then plus. I'll have the midterm, which was 25%, times the midterm grade, which was a 78. I don't have anything for the final because we don't know what the final grade is. It hasn't been weighed in yet. That's another important aspect of a weighted system. If something hasn't happened yet, it doesn't get weighed in. So I don't have plus 25% times, well, what grade would we have? A 0, a 5, 100? It would be a variable, and spoilers, that's what's going into the next bit, but we won't come to that yet. It's going to be a while. So weight times data, and then we stop because there's no more completed weights. So in the bottom, it's the sum of the weights that we used. It's not going to be 50 plus 25 plus 25. It's only the ones we use. So 50% plus 25%. So again, I don't count the 25% of the final because the final hasn't happened. Now you might say, well, Mr. Beckner, all of the homeworks haven't happened. That doesn't matter. As long as you have at least one homework grade, you have a homework average, then you do include the homework bits. So even though the homeworks have not all been completed for the semester, we still count that 80 average as 50% of the grade. That's how we're able to calculate grades before the end of the semester. That's how you will be able to calculate your grades before the end of the semester. All right, so we're going to do all the math here. Pull out our calculator. So we got 50%. I'm not going to write the percentage in this because I can't. So 50 times 80. And then we can just drop the percent symbol for reasons in this instance. So that's going to be 4,000. The 25 times the 78 is going to give us 1950. Let me do this. Perfect. Oops. I say that a lot here, don't I? Weighted average. So that'd be 4,000. That was the 50 times the 80. Plus the 25 times the 78 is 1950. Over 50 plus 25 would be 75. I'm not showing that in my calculator. 4,000 plus 1950, that would be 5,950. Divided by 75. So let's do that division. 5,950 divided by 75. And we get 79.3. And it's 0.33333. I could write 0.33 if I wanted to, or 0.3 or 0.3 bar, whatever Mymathlab tells you to round to if this was an actual assignment. In terms of your actual grade, we know teachers only deal with the whole numbers, so your grade would be a 79. So that's our weighted average. And then you can ask yourself, does this make sense? Like you're supposed to do after every single problem in this course. All right, so we had an 80 on our homeworks and a 78 on our midterms. Well, a 79, I feel like makes sense because it's somewhere between these two. If I calculated my average and it came up to be a 33, that would not make sense because I don't have any grades even close to that zone. I don't know why I was saying remarkably close. Relatively close, whatever R word I was going for. If I have grades of 80 and 78 and I calculated my average to be a 95, that would not make sense. So your weighted average needs to be somewhere between the numbers given. On top of that, when you only have a couple categories, you can actually tell which one it should lean towards. Since the homework counts as more of the weight, it counts as more of your grade, it has more importance, so to say, then the average should lean more towards whatever the homework is. So with an 80 and a 78, this has more importance. So that means the average should be closer to 80 than 78. And before we rounded, 79.33 was a little closer. Now, when you've got a whole bunch of different categories, it can be quite difficult to confirm that it's closest to the right one, especially if your grades are varying wildly. These did not vary wildly. But again, the make sense aspect really helps in terms of if you got an answer of, say, 45 here, or 71 here, or 95 here. None of those would make sense because they're not even in between all the grades given. So this is the most important aspect of a weighted average for you, the student, but there's still important aspects to weighted averages in the real world that you can take once you're not students anymore. Scrolling, scrolling, scrolling. Such a long section. So I just want to kind of peek at the intro to this 2.2 section. Weighted average, you could just write your formula there if you wanted to. So what they have here is they're talking about tuition, fees, room and board, all that jazz for the 3 different categories of schools we talked about before. And these are enrollment weighted, which means if one of these, if any school has more enrollment, then their number would have more value. So like a school of 20,000 students, if they cost $10,000 a year, and then you've got a school with 100 students and they cost $1 million a year, the value would be a lot closer to the first one because there's 20,000 students versus 100 students. So 20,000 students would be the weight. There's a lot more, so it would say that number is a lot closer. Now, that million number was a little redonkulous and could have an ugly effect, but you get the idea. So that's how these numbers were acquired. And they say, take a moment to think about what this might mean. If they simply list tuition, fees, room and board for all schools and take the arithmetic average, which means add them up and divide by the total number of schools, they don't take into account the fact that, oh, there's only 2,000 students at Bowdoin. I don't know how to pronounce that. This has been at least 3 semesters of laughing at that. And they were paying 80,000, while some other school had 30,000 students, which was like 15 times as many, and they were only paying 20,000. So maybe these are 2 private schools, but one of them is just, I'm going to say that fun word again, redonkulously overpriced, and that's why there's only 2,000 people going to it. Whereas the one that's a little more moderately priced, at least for private school, that's why there's 30,000 private students. Well, obviously this isn't a private school, but I'm just trying to get a point across. Because this isn't just tuition, it's room and board and all that stuff. And 2017, tuition got expensive in the 2000s, as you know. So if you just average the $20,000, the $80,000 from those two schools, you get 50,000. 20 plus 80 is 100. 100 divided by 2 is 50. So 50,000 would be the average. But that's not representing the fact that there were way more students paying 20 grand than there were paying 80 grand. So it's a lot better to take that into consideration and weigh it. So that's what this does. They say, all right, the 2,000 students, that would be the weight from the smaller school, and they were paying 80,000. So 2,000 times 80,000 is kind of like our grade percentage times the grade we earned, then plus. And then the next weight is there's 30,000 students there times the cost they paid of 20 grand. And then the denominator is supposed to be the sum of the weights, not 80,000 plus 20,000. This is where you might make mistakes initially. So if you did 80,000 plus 20,000, you get 100,000, and ultimately you'd get an answer that wouldn't make sense. So the weights, the number of students is what makes them, the prices tend more towards them in the average. So 2,000 plus 30,000. You do the math, you end up with 23,000. So because there were a ton more, 15 times as many more students at Austin versus Bowdoin, the B school, because there were way more students, that average is a lot closer to what they're paying than what the other people are paying. So that's where these numbers came from, is what they were saying above. They were enrollment weighted. So this actual public 4-year school number of 19,000 takes into fact all these different schools with all these different enrollments, does a giant weighted average, and they came up with this number, which has to mean there's a lot of schools out there that are cheaper and with a solid amount of students as well. But I mean, who's paying $80,000 for a public school? That just seems weird. But I mean, it was just the point of the problem. All right, so guided activity 1, we're going to complete this together. They sit the weighted average formula in front of you again, and I will remind you one more time. This has to be memorized. It's not like you're memorizing some giant formula. It's more of a concept, because I could say you need to memorize it this way. It's weight 1 times data 1 plus weight 2 times data 2 plus weight 3 times data 3 plus weight 4 times data 4 plus weight 5 times data. I can make this formula gigantic. And then, of course, over the sum of the weights, weight 1 plus weight 2, et cetera, et cetera. It's a lot better to memorize this as a concept. Conceptually, it means some product at the top, weight times data plus weight times data plus weight times data until you exhaust them. That's what these little ends mean until it's done. Then the bottom is just the sum of the weights, but you got to make sure you're adding the correct values. So number 1, you buy 8 children's tickets at $5 a piece and 2 adult tickets at $12 a piece. I'm just going to keep the annotation on this screen. You're going to have to deal with slightly ugly handwriting for a few minutes. Sorry. What is the average price per ticket? Now you might say, oh, well, just 5 plus 12 is 17. 17 divided by 2 is 850. 850 is the average price per ticket. No, because they're talking about what was the average price you paid. So you'll end up buying 10 tickets total, and you want to know across those 10 tickets, what was the average price? So if you just took that number and multiplied it by 10, you'd get your total cost. That's how averages work. But because of the variability in cost, kind of like the variability in our grade weights, you have to do a weighted average. So I would actually answer question B first if you want to be technical about this. But what I'm going to do is, you guessed it, I'm going to do it wrong first, because that's what we like to do sometimes, so that we can say, does it make sense, and have it not make sense. All right, so weight times data plus weight times data. So maybe the 8 and the 2, the number of tickets are the weights, or maybe the 5 and the 12 is the weight. So this red is going to be for wrong. Let's say I say it's the $5 and the $12, that's the weights, weight 2, excuse me. And then the 8 and the 2, those would be the data, so D1 and D2. So I would say this weighted average, weight times data, for the children, you've got the weight was $5 times the number of tickets, which was 8. Again, this is wrong. Plus, then I said weight 2 was the $12 times the number of adult tickets, which is 2. So this is the children, this is the adults. Don't mix and match. Divided by the sum of the weights. So in this instance, I said 5 plus 12. 5 times 8 is 40. 12 times 2 is 24. 5 plus 12 is 17. 40 plus 24 is going to be 64. And 64 divided by 17, I can't pull up my calculator right now without taking an extra 2 minutes, so I'm doing this on my own. You get 3.76. Does it make sense? What is the average price per ticket? $3.76? What? No, that doesn't make sense. Some of the tickets cost $5 and some of the tickets cost $12. In no world does this make sense. How is the average cheaper than the cheapest ticket you bought? So that tells us if you didn't goof the math, which we didn't, that means you goofed up what you assigned datas and weights. We flip-flopped them. So let's clear our screen and let's do it right now. Remember, if I'm moving too fast, pull up the YouTube later and pause. Weighted average. So it's really that the number of tickets purchased are the weights. So that's the first one and the second one. And the ticket prices are going to be what we call the data. And I understand that it feels like the cost could be the weights. I understand that at first glance, but that's why I specifically am doing this problem for us, because it's actually the number of tickets. It's easy to get this confused. This is the thing that when we roll up, we can have an effect on. And that's not actually the typical thing, because with grades, the thing we have an effect on is the grade earned. We can't affect the price here, so it feels like it would be the weight in that regard, because we couldn't affect the 15% or the 20% with our grade. But it's a little flip-flop there. All right, so weight times data, so that's for the children, 8 times 5, plus for the adults, 2 times 12, over the sum of the weights, which is 8 plus 2, right? Yes, 8 times 5 is still 40, 2 times 12 is still 24. See, the top actually doesn't change at all. The 40 plus the 24 is still going to be 64, but the bottom changes drastically to 10, and 64 divided by 10 is $6.40. And yes, that does make sense, because this value is between the two different prices we're paying. 640 is between 5 and 12. In an extended, does it make sense? And I'll say yes, it does. We bought more children's tickets, so the average should be closer to the children tickets price. If I flip the 8 and the 2, if I bought 8 adult tickets and 2 children tickets, I would expect this average to probably be like $10.50 or somewhere in that ballpark, plus or minus 50 cents. I would expect the adult tickets to govern more if we bought 8 of those, so the average would be closer to its $12. Now, again, if I've got all sorts of categories, if there's military tickets for $7.50 and student tickets for $8 and senior tickets for $3.50 and babies get in for $1, then it becomes a little more saturated and difficult to tell if that number makes sense. And you just got to hope that you've practiced enough to get it right. So what were the actual weights in this problem? It was the number of tickets. On time, 40 minutes, okay. And, oh, I'm not scrolled down enough. Well, I can do the work for A. So for number two has the exact same question. What are the weights? So where can I do that? I'll put it up here. 2B, what are the weights? So I have drastically spoiled this already, and I'm going to answer 2B first because I think it's important to answer the weights before you do the math, assuming that you can get everything correct. Alternatively, you do the math on a simple problem. If the answer doesn't make sense, your weights are probably wrong, or you could have just goofed in your calculator. Remember, your calculator is not perfect, especially if you don't know your calculator. So your grade consists of a test worth 80% and a paper worth 20%. We got a 70 on the test and 100 on the paper. This course is completed. It was a very simple course. Test 80%, paper 20%, not even remotely close to QR, right? We got a 70 on the test and 100 on the paper. So part B, what are the weights for this? It's obviously the 80% and the 20%, what the teacher assigns as the quite literal weight of the grade, the percentage that it counts as. All right, so what grade do we get in the course? Well, we got to do the formula, weighted average. So the weights are the 80% and the 20%. We just got to stack the 70 and the 100 with them appropriately. So weight times data plus weight times data, and that's going to be it. There's only 2 categories. The first weight for the test is 80% times its data. We got a 70 on the test, not a 100, a 70. Plus the paper was worth 20%, that's its weight, times the data is what we actually earned, which is 100. Don't forget to divide by the sum of the weights, which was 80% plus 20%. 8 times 7 is 56, so that's going to be 5,600. 2 times 1 is 2, so we're going to just stack our zeros. Sorry, my dog is distracting me. He's borking. 2,000 over, and then 80 plus 20 is 100. Now, some of you might be saying, well, instead of writing 80%, 20%, can I write 0.8 and 0.2? Because that would be the decimal equivalents. Absolutely, you can, as long as you're consistent. If you do percents in the top, you better do percents in the bottom. If you do decimals in the top, you better do decimals in the bottom. I'm going to have to go over here. Sorry, I don't know why I didn't put the weighted average over there. So the weighted average, 56 and 2,000 is going to be 7,600 divided by 100. That's really easy to do without a calculator. Just cancel the zeros, and you get a 76. Does that make sense? Well, again, with only 2 categories, we can definitely confirm if it makes sense or not. Because the test is worth so much more, our grade should lean closer to the test grade. 70 on the test, 100 on the paper. It would be awesome if they were worth the same and we got an 85, but no, the test is worth way more, so the grade is going to be a lot closer to the 70 than the 100, and 76 is definitely closer to 70 than 100. So yes, it makes sense. All right, I wish I didn't have to clear the whole screen, but I'm gonna, because the next question is going to relate to that. So really quickly, I'm just going to 80% times the 70 plus the 20% times the 100 over the 80% plus 20%, da-da-da-da-da-da, we got a 76 as our grade. I just want that up there. And I still didn't give myself enough room. Dang it. There we go. Sorry for that. This is why I don't like using this mode. It was 80% times 70 plus 20% times 100. And I can't even read these numbers anymore. I now have a bar covering that for me. 80% plus 20% equals da-da-da-da-da. We got a 76. Okay. Now assume, now we're in question 3. Now assume there are 2 exams worth 40% each and a paper worth 20%. I just wanted that completed for while we're working on 3. You get a 60 on the midterm and 100 on the paper. What is your grade at this point in the course? This is what I was talking about a lot earlier relating to your grade. We haven't done a midterm, we haven't done a final, we haven't done a project. So 45% of our grade isn't even being weighed in yet. You don't use weights that aren't being weighed in yet, that you don't have grades for yet, so to say. Now be careful, it's 2 exams worth 40% each. So exam 1 counts as 40%, exam 2 counts as 40%, and then the paper is the final 20%. So the 60 on the midterm is not 2 tests, it's just one of them. Oh, this dog, he's funny. Distractions. So we only have 1 exam so far. So we're not going to have 40 in there twice, we're only going to have it once. So our current weighted average with just these 2 grades, it's going to be the 40% for the midterm times what we got on it, which is a 60, plus we don't do the 40% for the final because we don't have a grade yet, and then it's the 20% for the paper times the 100 we earned, divided by. Do not add up all percentages, just the ones in this formula. The 40% for the midterm, which we have a grade for, plus the 20% for the paper, which we have a grade for. No grade on the final, don't put it in the weighted average. 6 times 4 is 24, so that's going to be 2,400. 2 times 1 is 2, so that's going to be 2,000 over 60. The top is going to become 4,400 divided by 60. That's a terrible looking 6, isn't it? And if you do that division, you end up with 73.3. And again, you could round to the nearest whole number because that's what your teacher's going to do anyways and call it a 73, but I'm just going to stop there. Does it make sense? Well, the exam counts for more than the paper, so yes, your grade should be closer to the midterm grade. So an 80 would be just splitting the difference of 60 and 100 if you added 60 and 100 and divided by 2. But there's weights here. All right, I got to stop my dog. He is extremely distracting. Give me 20 seconds. All right, I'm back. B. So A is like we're halfway through this. Are you serious? He stopped for all of 2 seconds. Okay, I'm just going to try and not be distracted. Good luck to me. So A was like we're part of the way through the semester, kind of like we are right now with quantitative reasoning, kind of like we are with most courses. B, now we're going to think about, well, at the end of the semester, when we take our final, because we're now just doing with these 3 categories, what is the highest grade we could get? So what we're saying is for part B, all the stuff in part A is still in effect. We still have the 60 on the midterm. We still have 100 on the paper. But now we got to say, you know, based on whatever grade on the final exam, what's the highest grade we can get? Well, if you want this to be as high as possible, and this is drastically different from that example you saw in my notes earlier, if you want this grade to be as high as possible, what do you want to earn on the final? You need to assume on the final that you get a, that's right, 100. that would earn you the highest possible grade. Now, maybe you wanted to know what's the lowest possible grade you can get in this class, then you call the final a 0. What that would do is give you a window of where you could end up. Some people like to go, you know, hey, if the final exam is only 10% and I have hundreds on everything, do I even need to take the final? Well, technically, in that very, very rare instance, no, because you'd lose that 10% and you'd still have a 90. You'd have an A and you're good to go. So we're going to assign the final as a 100. So now our weighted average is a 40% times the 60 plus the 20% times the 100. Doesn't look like there's a times in there. Plus now the 40% for the final exam times the assumed magical 100 grade, which is extremely hard to earn in a QR class, divided by, now my other dog is scratching himself on my desk and knocking it. Hey, buddy, hey, come on. Okay, so divided by the sum of the different weights, the 40% from the midterm, the 20% for the paper, and the 40% for the final. So we do have everything completed at this point. Yes, LOL indeed. All right, so 40 times, all of the first bits are still the same, so that's 2,400 plus 2,000 plus the 40 times 100 is going to give us 4,000 divided by 40 plus 20 plus 40 is 100. Adding all of those up, that's 4,400, 8,400 divided by 100, cancel the zeros, and you get an 84 as the highest possible grade that you can earn. So what that means is you can't make an A, unfortunately. That midterm you earned a kind of low grade on had too much of an effect already. Now, these tests were weighted very, very heavily. Your QR teacher is a lot nicer, and it's just 20% for each test. Now, we don't get a lot of classes, especially in community college, where your grade has got tests worth 40% each. But if you go to grad school or 400 level classes, you certainly could have that. I know I had a class where the whole grade was a final. That was it. There's no midterm, there's no homework, it was just one final. It was quite terrifying for most everyone. All right, so you can earn a B, but you don't have a lot of wiggle room with this B, do you? So an alternative approach to this, what is the highest grade you can earn? Maybe you just want to say, well, what grade do I have to get on the final exam to earn a B? So what grade is the minimum to get a B? Can I get a 82 in the final? Can I get a 78 on the final? Can I get a 61 on the final? That's going to be a little more of an algebra problem. That's what I had in my own notes. We'll come back to that later, though. We still want to do a little more practice with this idea. Okay, so let's go off of annotate, scroll down, and here we go. This, ow, it just wheeled over my foot. This is a great day, isn't it? This is going to feel a lot more like our actual course because we got a homework category, a quiz category, projects, midterm, final. So it's missing one column or one category. Doesn't have actually two columns. It doesn't have participation and it doesn't have Excel homework. But again, I'm not saying this is our class. This is some other class. It's just a little more similar. It's similar in some ways that these grades are scaled differently as well. Look at these homework grades, 7, 8, 6, 10, 9. These sound awful, but what that probably means is these homeworks are based on a 10-point scale. If I don't see anything over a 10, I'm going to assume the student isn't doing terrible. I'm going to assume that was a 70, an 80, a 60, a 100, and a 90. Same for the quizzes, a 70, a 90, a 75, and a 78. So that's something to consider with these averages. The average isn't really an 8 and a 7.825. When you think about everything on a 100-point scale, which makes our brains hurt less, this is really an 80 and this is really a 78.25. This is something I've already mentioned is an issue with any grades I post in Canvas because I usually just put the grades based on points. So if there's 4 questions, it's 4 points. If it's 10 questions, it's 10 points. Also, you might see those participation grades, which are often 1 or 2 points that really isn't supposed to affect your grade at all. They're just 100s, not ones or twos. So that is an important aspect to understand here because it mildly relates to you, especially in the Canvas section. So you would need to rescale your averages there, or rescale the individual grades even, because my quizzes are done with all sorts of systems. So you have to say, oh, okay, well, this one was worth 5 points and I got a 4. 4 to 5 is a 80. Or this one was worth 4 and I got a 3. 3 out of 4 is a 75. You just do the division and it gives you the number. That's all it is. All right, so the point of this is, what formula is in cell B16, which is right here where the 8 is? So it's not 8. We want an Excel formula, so equals blah, 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 blah. What is the student's grade in the class right now? And then what will her grade be if she gets 100 on the next project and a 95 on the midterm? I need to pull back just a little bit so I can get all this on here at once. There we go. Let's go to annotate. What formula is in cell B16, which is right here? Well, it's a formula, so equals. There is a word staring you in the face which tells you exactly which Excel function. This is the average of all the homeworks. This is the average of all of these homework grades. So it's preventing you from having to add up 7 plus 8 plus 6 plus 9 or whatever and dividing by 5. Because then when the next one is, you then divide by 6. So that average is not, it is not just applied to these. It is not just applied to what I have circled. It is not just applied to those. Because we need to have this formula set up so that when this grade comes in as a 10 and this one comes in as a 2 and this one is a 5.9 or something, that this number changes to a 8.5 and then a 7.8 or whatever it might be. So, average. Don't abbreviate it. This is the word, and we have talked about that one before. We've used sum a lot more, but we do use average here and there. And then you need to take the average of all the important cells. So you're supposed to go the first entry, colon, then the last entry. The first entry is obviously where this 7 is, which is cell B3. Okay. Where does it end? Well, it doesn't end here. It does not stop here because then it wouldn't account for the rest of these. So it actually has to stop at this cell where we said, all right, we're only going to have up to 12 homeworks. So you got to know how many homeworks are possible in the future. Well, this cell, it's not 12, it's not B12, it's B14. 12 is just us saying, hey, that's the 12th homework. So that's the formula in that cell. What is the student's grade in the class right now? So this is where we switch to our weighted average. Remember, going across a single category is just add them up and divide by the number of them. When you're going across separate categories like now, it's a weighted average. So our weighted average will be, well, let's do the homeworks first. So the homeworks count as 20%, so 20% times the homework grade. Now you don't have to do anything with the 7, 8, 6, 10, and 9. Excel already did it for you. The homework average was an 8, but you don't just write 8. That would be wrong because all these other grades, this project was a 93. We're going to have a 95 on the midterm later. So let's make everything the traditional 100-point scale. So let's call the 8 an 80 plus. Next, the quizzes. So we'll have 20% for the quizzes times not 7.825, 78.25, and do not round that, plus. Now the only other grade we have this far is a project, and it's a single project. Notice it says the word each. That is critical. It's not add up all the projects, divide by 5, and then that grade's worth 8%. It's 8% each. So the 93 is 8%. This 95 we'll have later, which is not part of it yet, will be 8%. So your 8% times the 93, and then we divide by just the weights we've used, which were the homework of 20%, plus the quiz, which was 20%, plus the single project, which was 8%. All right, so 2 times 8 is 16, so that first one is 1600 plus 78.25 times 20 is going to give us 1565, plus the 8 times the 93 is going to give us 744. Confirm those with your own calculator. 20 plus 20 plus 8 is 48. Then adding up the 1600, the the 1565 and the 744 is going to give us 3909 divided by the 48. And you'll get 81.43, blah, blah, blah. Let's just call that 81.4. Or an 81 when you round to the nearest whole. Again, I haven't specified how to round. Yes, you know your grades are typically rounded to the nearest whole. And maybe not rounded, maybe something known as truncating, because some teachers are not super nice. You know, if you earn an 89.9, some teachers will go, yeah, that's an A. 89.9, let's round up to 100. But some teachers will say, no, sir, no, ma'am, 89.9, it's a B. So that's known as a truncation, when instead of rounding, you just call it an 89. That's called truncating it. You just delete the decimal. You don't account for it. All right, part C, beefing it up a little. Now we got some more grades. Still not a completed course. We got 100 on the next project. So with part B, now this is 100 and a 95 on the midterm. So again, where this grade is, in Excel, there's a formula here, equals blah, 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 blah. That would calculate it for you as you typed in those grades, and it would do all of that for you. The actual formula you need to account for the blanks and stuff has some if-then statements or using the count function. It's something that's a little above your pay grade, which is why I said I'm going to just kind of set up that formula for you, but you will have to type it out. I will show you exactly what the formula looks like, not today, but you'd have to type it out. Okay, so weighted average. Now we still have all of the stuff from before, the 20% times the 80 plus the 20% times the 78.25, that's homework and quizzes, plus project 1, 8% times 93, plus project 2, 8% times we got a 100, plus the midterm, which was 10% weighted at a 95 grade. All over, so we're still missing 3 projects, we're still missing the final. So this bottom is not gonna be 100, it's 20 plus 8 with percents, of course. Sorry for the rushing, getting close to time. Now we also have the extra project, which was another 8%, plus the midterm, which was 10%. Let me do this. This number right here, we already know that was the 3909. That's not going to change. But the 8% times the 100 is going to be 800. The 10% times 95 is just going to be plus 950. Sorry about that right there. Then divided by, the bottom was 48, plus another 8 is 56, plus 10 is 66. So again, that's 3909 plus 800 plus 950. There, that looks a little better. Okay, so when we add, I dropped my calculator, 3909 plus the 800 plus the 950, we should get 5659 divided by the 66, and we'll get an 85.7, which again, your teacher might round up to an 86. They might just call it an 85. In this instance, it wouldn't affect you since it's a B either way. If you were in a plus minus system, it depends on the school. If an 86 is the B plus or if an 87 is the B plus, but we are not on a plus minus system. Makes grading a lot easier. Also, I feel like it makes students freak out a little less. I'm sidetracking, I know. Either way, I'm not going to sidetrack. I'm going to stop. Now you might want to ask yourself, does this make sense? And you might go, well, how am I going to say if it makes sense? There's all sorts of categories. I'm not going to be able to say what this number should be closer to. What you can say in terms of making sense of it here is, did your average from B to C go up or down, and should it have gone up or down? So we went from an 81 to an 85 and some change. Well, the new grades we earned were higher, 100 and a 95. So yes, it makes sense. If we had an average of an 81 or 82, and we then earn 100 on some assignment and a 95 on some assignment, our grade should go up. How much should it go up? It gets difficult to say. It's going to be very hard to make sense of that side of things. But it didn't shoot up to a 100 instantly, so that's a good sign. It didn't just stay right by 81 because 10% of the grade was a 95. That's a pretty large chunk. 8% was 100. That's a large chunk. So it went up a few points. I'd say that's in the realm of sensibility. Now again, Excel can do all of this for you. You don't have to do these hand calculations. You have a formula here. All you gotta do is just input grades, input grades, input grades, and this thing will update as you progress. All of a sudden you put in your final of 200, excuse me. Why did I say 200? I wasn't even close to the number I wanted to say, of an 87. So you put an 87 here, and then all of a sudden your grade would change. It wouldn't become a 200, that's what I was trying to say. It would probably go up maybe a few points or down a few points based on proximity of where your grade was before. All right, so last problem of the day. Back to the notes. The stuff I said was a little more above and beyond what we originally did. So same example from earlier, weights are 50% homework, 25% midterm, 25% final. Currently you have an 80 on the homework and a 78 on the midterm. What grade must you at least make on the final to get a B average? This is a question a lot of people ask themselves, and they might want to ask their teacher, and they'll go, well, I'm not going to calculate that for you. That's more complicated, especially if you have 150 students asking the same question. This involves a little algebra. Everything else we were doing was just arithmetic. This will be algebra because you're going to have an unknown as one of the grades, and the final grade is what's going to be known. So we're going to use the weighted average formula, but we can't assume a number for the final exam. That's what I'm saying for final here. We need to make it a variable, and what I decided to call it is X. That's just a parentheses around it. If you wanted to call it F for final exam, you could. If you want to call it T for I don't know why, but you could. And then we said we want to get an 80 as the ultimate average. So instead of us just crunching down numbers and getting the answer, we set it equal to 80 to achieve this goal. So this is going to look a little different. So let me kind of circle things as I talk about it, since I already have this up and we only have a few more minutes. I would not have time to replicate all of this. So we're setting the weighted average equal to 80. So I would normally say weighted average equals blah, 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 blah. We crunch this down and get a number. We're assuming it's an 80 because that's what we want to get in this class. Obviously, we want an 80 or higher, but an 80 is the minimum, so that's the standard we set to it. If we wanted an A, we would instead set this to a 90. If we wanted a C, we would set this to a 70. We would not set it equal to a 60 or anything less because we don't want D's or F's, right? Right. So what's going on? This 0.5 was the 50% for the homework. And then the 80 was the 80 we already had on it. Then this 25, and I did this as decimals just to mix it up. I mentioned this earlier, so if you don't like writing 0.5, you could instead have written 50% here. You could have written 25% here, and you could have written 25% here. And then this on the bottom would also be 50%, 50%, 25%. You just have to be consistent. All right, so back to where we were. We said the 50% was the homework. The 25% was the midterm, and the midterm grade was the 78, so that's there. But then we're trying to figure out what we need on the final exam. So we are going to include it this time. What do we need on the final? So here's the 25% for the final. We don't know the grade, and that's what we said we had to call it X. Then the bottom is just the sum of the weights, the 50 plus the 25 plus the 25, or 0.5 plus 0.25 plus 0.25. Again, just wanted to do this the different way so you can see it works. Now what we've got here is an equation, and we have to solve this for X, because this is our equation, all of that together. So I want to undo all this circling of things so it doesn't look like a mess. I wish I could have like just a state frozen. That's okay. So that got ugly, didn't it? Just ignore what you're seeing for now. I'm going to show the work. So what we had was the 80 equal to. Now the 0.5 times the 8, well, 5 times 8 is 40. So, I'm sorry, 5 times 8 is 40. That would say it's 400, but there's a decimal, which makes it 40. Plus the 0.25 times the 78 is 19 and a half, so 19.5. Plus the 0.25 times x stays that. You don't actually get to multiply that out because it's got a variable in it. Then divided by 0.5 plus 0.25 plus 0.25 is 1. This is another reason I did this problem this way. With this particular setup, it is actually a lot easier if you make the percentage weights the decimals instead of the percents, because otherwise this would be 100%, and you would have to multiply both sides by 100 to clear that fraction. Dividing by 1 is literally just don't write it. So this is 80 equals 40 plus 19.5 plus 0.25x, which 40 plus 19.5, it's going to give us 80 equals 59.5 plus, I did not add the 0.25 because that's not how algebra works. And then we just got an equation we have to solve. This needs to be subtracted, so we subtract 59.5 on both sides. Again, you can use your calculators to confirm these numbers on your own time. But 80 minus 59.5, that's going to be 20 and a half. We get 20.25 equals 0.25x. Doesn't matter, that's a decimal, just divide both sides by 0.25. Yes, you can multiply both sides by 100 to clear decimals like this, but you don't need to do that because you're using calculators anyways. And you'll get an 82. Oops, wrong color. Not that it matters. So 82 is the grade that we need to earn on the final exam at a minimum. If we want to earn a B in this course, we have to at least get an 82. And that's because our grade isn't even an 80 before the final. So yes, we have to make higher than an 80 to actually pull that up. What you might want to do for fun is go back and say, okay, well, what would I need to earn what would I need to earn on the final exam if I want to get an A? So for an A, you'd go 90 equals to, and then the right-hand side is literally the same thing. You'll solve it and you'll get an answer. Now, let's pretend we got 105. Can you actually get an A? If you need to earn a 105 on the final exam, could you actually get an A in this course under the assumption that there's no bonuses, no grades over 100s, which we don't do in QR. Hundreds are hundreds, that's the best you can do. Then you say, no, I can't get an A because I need more points than possible to get that A. So if this grade is ever higher than a 100, that means the grade is not achievable under normal conditions.
And we're going to call it there and skip the last 10 or 15 seconds since I know we're pressed on time. This was up at the beginning. If you missed it, the replay should be available sooner than later. Again, it's always available same day. It just takes a while typically because, other things are going on, compressions, blah, 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 blah. So have a good one. Get everything done that you need to. Email me if you have any questions. Please remember to say which time and class you're in when you email me. I'm having a major problem with that still from the students. But besides that, take care and we'll see you Thursday. Oops, wrong button.